So, if you have not already, please go ahead and install Visual Studio Code if you've got your laptop and you want to follow along. Polyglot Notebooks are an extension within Visual Studio Code, and then you can kind of follow along for a bit of this and play around with it, ask questions. We'll figure this out together. These are my ambitions for you, the learning objectives. So we're going to be creating documentation in Polyglot Notebooks, which is living documentation. How many people have heard of Jupyter Notebooks? Yeah, these are kind of the Jupyter technology applied to .NET and various related languages. So brought right into Visual Studio Code, and they can help you to communicate. And then through this, we're going to be talking about immutable data structures, how we can use immutability in .NET, and then what that has to do with identity, as in what's the identity of an object, which seems like a pretty simple concept, but then when you start to really dig into it, it's like, you make some really important decisions when you decide how you identify objects. And then we'll kind of bring those ideas together, and we'll model a full system using immutable records identity. And that's where I'll bring in an open source project that I've been working on for a few years now. It's called Janaga. And I'll show you how Janaga works really well inside of Polyglot Notebooks in order to model a system. So, after you've installed the Visual Studio Code, you can go out to GitHub and go to github.com/michaellperry/immutability, and that's where you can grab the source code if you wanted to follow along. That's also where you'll find this link, so you can go to that repository and hit the link, and you'll be at the repository. Sorry, recursive joke. If you didn't get it, try one more iteration. Okay, so let's start things off. I'm going to keep this notebook open, but I'm going to actually be doing all my work in a different notebook so that we can kind of see things jump back and forth. So once you have installed Visual Studio Code, there is an extension. Let me go to the extensions thing here, and we can look for Polyglot, and we'll see Polyglot Notebooks pop up right there. So this is a feature that will let you open and edit these notebooks inside of Visual Studio Code, and they support C#, PowerShell, JavaScript, SQL. We're going to be playing with that one. So we'll mostly be doing C# and SQL, but also taking advantage of the HTML rendering support. You can't just type HTML, but it'll render HTML, which is going to be very useful, as we will see. So you can just search for Polyglot Notebooks, get that installed, and follow along. So first thing that we're going to do, Control-Shift-P to open the command palette, and then type Polyglot and create a new blank notebook. So it asks you this question, which when you first install it, you have no idea what these two things are. But IPYNB is the file format for Jupyter Notebooks. So that is a well-known standard open file format. DIB is Microsoft's format where they're experimenting with new features. I always choose IPYNB. Oh goodness, IPYNB. Yeah, I think that's probably it. Yeah, interactive NB. Yeah, that's probably it. Interactive Python notebook. But I have no idea what DIB stands for. But the primary difference between the two. So in a notebook, you can type code, and then you can run the code, and the output shows up inside of the notebook. And you mix that with Markdown in order to create a document.
The primary difference between the two is that with DIB, it doesn't store the output in the file. But with IPYNB, it does. So if you were to share an IPYNB with somebody else, you would share your results too, which is why it's really powerful for Jupyter Notebooks, which are used in data science and other scientific communication, because you want to do some analysis on your core data set and then share your results, even if you don't share the core data set with somebody else. They should still be able to see the results. But if they also grab that core data set, then they can tweak your analysis and they can come up with different results. So, pretty powerful stuff. So I've chosen IPYNB so that we can store our results. And I'm also going to choose C# as the default language. So that means I can drop into a code block here. I can select any of the other languages. For the most part, I'm going to be sticking with C#. So in here we can type some commands like let's say string name equal Michael, and then I can hit the run button, execute the cell, and have the output below, or I can just hit Control Enter. I'm just going to be doing Control Enter, and you see, hey, I ran it, but it didn't output anything. That's because that's what I typed there is a statement. If I end this block with an expression, which means I don't have a semicolon at the end, this is just an expression, then when it outputs, it shows me the result of that expression. So it's going to be the kind of stuff that we do too. And then of course I can have markdown in here, to say stuff. So type in my markdown, and then if I Control Enter, then it formats the markdown. That way I can create a full document. But let's go back and let's create another code cell. Now let's start talking a little bit about immutability. Now that we know what our tool can do, let's play around with it. So in C#, there's a brand new language feature that helps us with immutability. Does anyone know what the name of that feature is? Records. Nice. So we can define a record. Like I'll define a record called person. And then you can already see Copilot is recommending what I want to come next. So right after person, we can give it the parameters for that record. But a record is like a class. It defines objects. So what are these parameters? These parameters are the constructor parameters. This is a default constructor, which, by the way, now in the latest version of .NET, you can have default constructors on the classes too, but they were first introduced to the record. So yeah, let's go ahead and do string name. I like to use lowercase letters for these. There are reasons that you might want to use uppercase. We'll talk about why. Yeah, sure. Let's do the age as well. So I'm going to end it with the curly braces. You could also just end it with the semicolon. I'm doing the curly braces for a couple of reasons. First of all, it helps you to remember that this is just like a class. You can add more stuff to it. So inside of these curly braces, you could add methods, you could add properties, you could just anything that you want to do like you would a class. But by default, what you get out of this is that these are not only constructor parameters, but they also become properties. And they're also used to implement equals and get hash code. So all of the stuff that you would normally do in order to create a data object, the default constructor or the primary constructor, is what this is called, generates all that for you. Because it is a record, what it is generating are immutable properties. They have getters, but no setters. They must be initialized by this constructor, which helps us to do some really cool stuff. So I can say, here's Michael, and so, oh, it's so kind. Copilot thinks I'm 30. How cute. Let's go ahead and fix that. This is going to become obvious anyway. So then I will say, okay, let's go ahead and create that person and render that out. So now we've got this person record. It has a name property and an age property. And because they used lowercase here for the parameter names, I get lowercase property names. So that's kind of the trade-off. That's why some people will use uppercase, so they get uppercase properties. But then it also kind of renders it out as this little table here, so we can see all the different properties. That way, if I had a list of these, I would get a nice little table of all the different values in the columns and all that stuff. So it tries to render the output in something meaningful as well. But now that I've got that, I cannot do Michael.name is equal to, well, I really want my full name, Michael Henry. It says, nope, cannot do that. This is an init-only property. It means you have to initialize it in the constructor. Records are immutable. So why would I want to use an object that I cannot change? It's basically taking away a feature. Any ideas? Why would I choose to do that? That's actually really accurate. Yes, I do not trust myself. I'm going to be writing some code, and then I'll decide, hey, I need to change this property, and I just change it. And if I didn't have the compiler watching out for me, then in other parts of my code, I might not expect that change. And then I get a side effect out of a function that I think should be side effect free. So to help me really think about my code, I really want to enlist the compiler's help in enforcing the decisions that I made up front. And so I can decide to be immutable. So immutability is a decision. It's a design decision. This isn't something that's going to help your code be more secure. This isn't protecting you against malicious attacks on your code. This is protecting you against yourself. And it's enforcing a design decision that you make up front. So let's now talk about what that design decision means. What is the reason for that? Let me go ahead and delete this one, because that one is a big error. Come back to this one. So I have made this design decision that the name and age of a person are immutable. Is that a valid, useful design decision? Yeah, there we go. Yeah. So I chose age here in order to produce a demo. But if you were doing a real system, age changes over time. So you don't want to make that immutable. Instead, you want to choose something like date of birth that is immutable. And I am not too proud to go ahead and put in my, I was born in 1985 on January 1st. 1971 on, nope, not October, May 10. There we go. There we go. So now I've done something. I've modified my design, and I've chosen something that truly is immutable. And then from there, I can calculate things like age. So if I wanted to write a function that returned the age of person. So this function is a little bit more complicated than all that. There we go. Let's see. Yeah. Okay, it figured it out. This is one of those cool things that Copilot can do. I've expressed my intent. I want the age of a person. I've expressed the data type. It can see the data types declared elsewhere in the code. And then it says, okay, in order to implement that intent with that data type, this is what I will do. And it's not too bad. It got the casing wrong, because that's date of birth with lowercase d. But yeah, we can fix that with a little bit of IntelliSense. So now it's saying that if the current date is, what's that? Yeah. Yeah, so I think it's, yeah, I think what it's trying to do, yeah, because time span, calculate number of years. But I think what it's trying to do is compute your age the way that a human normally would. So, if in the year I have surpassed my birthday, then I am a year older. Whereas with time spans, if you, the time span doesn't know if you started or ended across a leap year, so it could be off by 1 day. So, yeah. And besides, time span has total days, but it does not have total years, probably for that same reason. It doesn't know how long a year is. Yeah. But, so now I can say, what is the age of person Michael? And it says, okay, now it's 52. And if I call that function next year, it'll say 53. So we have separated what's immutable from what's mutable, the things that change from the things that don't. And we can calculate the things that change based on the things that don't change. So this is one of those concepts that has become kind of popularized with the phrase event sourcing. So how many people have heard of that idea? How many people have you actually used event sourcing in any of your systems? Nice, excellent. Yeah, event sourcing is the practice of capturing history and then computing current state. The neat thing about history is that history is immutable. You record a thing, it happened. You're not going to go back and change your record of what you say happened. But instead, you can record new history and evolve the current state from that. So that's one of these things, one of these places where immutability becomes really, really powerful. So now, so far, the person name that I put up here is just my first name. Let's go ahead and put in my full name. It'll still compute the same age of person. But now I'm giving a better description of this individual, this person. Although I cannot guarantee that there was not more than one Michael Perry born on May 5th, 1971. So that's not really enough to identify that person. Furthermore, names themselves are not immutable. So really, in order to turn this into a truly immutable object that identifies a person, we would want to do something even more rigorous than this. So we might, for example, say Social Security number. I am not going to complete that constructor, because if I did, you could steal my what? Identity. Yeah, I'm sure it'll only take about 20 minutes to find it. Especially if I gave you my last 4. Yeah, you could crack it pretty quickly. I don't know why people think that that's a secure way to prove your identity. But yeah, let me go ahead and change that back to name. But yeah, so even though a Social Security number is not issued at birth, still that combination of SSN and date of birth is sufficient to uniquely identify a person. SSN by itself is not, because they could be reused, but that person that it's reused on will be born on a much later date. So you're good with the pair. So yeah, that is not just an immutable record, it is also an identity. Conversely, if you use something as your identity, you don't want it to change, so therefore identities should be immutable. So these two concepts are really so closely interlinked that sometimes it's hard to tell the two apart. And where you're going to see some of those sometimes. Okay, so let's talk a little bit more about immutability. There are some other tools in .NET that help us with immutability. There are some data types that I'm quite fond of using. So I can say, here's the letters. I might say I want to create a new list of characters. Look at that, Copilot, just figuring out what I mean by that. That's kind of awesome. But if I instead created an immutable, look at this, you've got all these different immutable types. I'm going to use an immutable array. Now, it doesn't know how to find immutable array. If I were in Visual Studio or if I were in a code file, I could just control dot and get the using statement. But here you have to say using system.collections.immutable. And now it knows what immutable array is, or it will once it runs. So an immutable array creates a collection. It fills it with some elements. And then you can't change that collection anymore. It's immutable. So let me go ahead and type out the letters. We got ABC. Perfect. All right. Now I want to add another letter to that collection. So let me add some more code here. I'm going to say letters dot add, and I'm going to add D. Okay. And let me type out the letters. Still ABC. Huh. I just didn't add. Why didn't it change the list? Well, yeah, that's a good guess. So yeah, it does implement some of the interfaces that you're used to, like IEnumerable and that kind of thing. But yeah, it does not implement the iCollection, which allows you to add in a mutating way. Instead, letters.add returns an immutable array. So if I were to say the new array is, let's go ahead and var declare that. And now we're to take a look at that. Yeah, letters is still ABC, but new array is ABCD. So add has a different meaning in immutable collections. It means build a new collection that has all the old stuff plus this new thing. So there are good reasons to use immutable collections in the algorithms that you write. And it comes back down to not trusting yourself, enlisting the compiler's help to enforce the design decisions you made up front. And so I want to explore one of those examples with you. What I have built in here, and so you will find this code in the repository. I've built this little tic-tac-toe class library. So this is some pretty nasty code. We're not really going to look too hard at the code for the tic-tac-toe game, but just to kind of show you what these things are about, we've got an enumeration that's XO or empty, tells you a symbol that's in a square. And then we've got a game. So we start with a public static read-only game empty. This is actually a pretty common collection, or a pretty common pattern in the immutable world. So I could say var more letters is equal to I start with an immutable immutable array of character, and then I say dot empty, and that gives me an empty array. And then I can do a dot add on top of that to get more stuff. So that will build up an immutable array like that. So it's kind of a common pattern that you have this static property that represents the empty collection. So I basically just used that idea here inside of the game, and here's my empty game. Inside of the game, I have an immutable array. So here I'm creating an immutable array of a bunch of empties. And then I'm saying that the next player is X. So that's basically a game state. Empty game where X is the next to play. I've got that private constructor there. So I just initialize those things. And these things are read-only. I'm basically, even though this is not a record, this is a class, I'm basically building immutable behavior into this class. So who's the next player? Give me a list of all the empty squares. So it's just returning that information. And then if I say play, I want the next player to play at this index. It returns the game. It doesn't modify the game. It gives me back the new one. So I'm behaving like one of these immutable data structures. And I'm doing that by virtue of the fact that I'm using immutable data structures. So I've got my immutable array of squares, and then I say set item, which is similar to add. It just does a replacement, but it does it in a way that it doesn't modify the existing one. It gives me back a new one that has that item in there. And then it gets a little bit ugly. Yeah, hey, who's the winner? I just let Copilot generate this one. So it said, oh, who's the winner of a tic-tac-toe game? Blah. Just look for any of these patterns. Fine, it works. Then this part right here, this is going to be really cool. Polyglot notebooks can render HTML. So if your class returns an HTML string, it will get rendered. This helps to see what is going on inside of our game. So I'm going to do a hash R, which lets you bring in references to DLLs. As you can see here, it's predicting, hey, you want to bring in a reference to the NuGet package, system collections immutable. So, no, don't need that NuGet package. It's now part of the runtime. Don't need that. But what I do need is /. Then we're going to go into tic-tac-toe, and then /, and we've got bin debug net70, bin debug net 7.0, and then we've got tic-tac-toe DLL right there. Okay. So yeah, just go ahead and pull in that DLL, and now I can use those classes right here inside of the Polyglot notebook. So let me go ahead and bring in the namespace, and then I can say var game equals not new game, because game is a private constructor, but what was the pattern that we use here? Game.empty. So now let's output that game as HTML. And there we have an empty tic-tac-toe game. So if I wanted to make a move, how would I do that? Come back here. We've got this play. It takes an index, the zero-based index, and it returns a game. So let me say I want to do a dot play. and then I just pass in the zero-based index. Copilot is trying to be really clever. Oh, okay, I want to play an X at position 1, 1. Nope, that's not the API that I've designed here. The next to player is X, so it's going to be an X. And zero-based, we've got 0, 1, 2, 3, 4, 5, 6, 7, 8. Let's play in the center, so it'll be 4. Now when I run it, okay. I've got a board that has an X in the center. So now let's go ahead and take advantage of the fact that this is an immutable data structure. I want to explore the next possible move. I could do that by mutating the board, putting an O in the first cell. And then I would have to remember to undo that move before I put the O in the second cell. But since this is an immutable data structure, I know that by playing an O into each of the cells, I'm not mutating the original one. And so I can go back to that original one, and I can say, keep playing from here, which lets me do something like this. I'm going to say all of the moves is equal to, starting with the game that I have, let's get all of the empty squares. So that's my collection of indexes that I could play into. And then from there, I'm going to do a dot select from that index. And then I will do game.play at that index and then render that out as HTML. So I'm doing that inside of a select, which means that it's going to do that for each one of the empty squares, and it's going to give me back that entire collection. So let me render that collection out. And this is what we get. These are all the possible moves that O could make. So I was able to express that very succinctly, very cleanly, because game is immutable. And I know that when I'm playing, I'm not changing the game. I'm just getting back to the next one. So this is the shift when you start to think about using things immutably. Okay, so now let's go ahead and say that I want to continue to explore this one here. So let's go ahead and make the move not 0, but 1. So from here, code, and now we'll say game is equal to game play 1. So now that's the game that we're looking at. Did I modify the game? No. What I modified is what the variable game points to. So kind of a little bit of a mind bend there. That you're not modifying the objects, but variables themselves can still be modified. But now that game is equal to this is kind of funny. If I were to come back up here, now game is that new value. So now I'm exploring all of the moves that X could make from that point on, which is kind of a funny little thing with immutable notebooks, is that even though they flow down the page, you can actually go back up and rerun code, and it takes the values that were set below. And it can get kind of tricky. But that's what this run all button here is for. If I hit run all, it just goes from the top down. So now we're reset. We're back to the state that we wanted to be in. Okay. So now I want to explore the space of possible moves, and I want to evaluate. I want to say, in this position, who do I predict will win? So anyone want to give it a guess? This is our position. Who is going to win? X is going to win. Yeah. Yep. Yeah, because unless X makes a mistake, they can now force a win from this position. Of course, My data structure doesn't know that, but I'm going to use the data structure in order to explore that space and see if I can find that out. So I'm going to take advantage of this property here of winner. And right now, winner is returning empty. Winner returns symbol, so it returns space, or empty, being space, X or O. So in this case, nobody has actually won, so winner returns empty. It's currently not a winning position. If I were to keep playing until I got a winning position, then winner would return X or O. So winner itself is just a projection of the game state. It's just telling me a little bit extra something about this immutable state that I already know. It's not the prediction. Let's go ahead and write the prediction. So I want to have a function that returns a symbol and evaluates. And so given a game, you can see it's already trying to predict what I want to do. Not doing a very good job of that prediction. So given this game, I want to predict who's going to win. Well, we can start with some trivial cases. So if the game first of all, grab the winner. And then if the winner is not none, then return that winner. Okay, not none. Empty. Then return the winner. Okay. So if I'm evaluating a game where somebody's already won, pretty easy prediction. And then for this, I will say if you have any, if you don't have any moves left, so if game empty squares, oh, look at that, it did the right thing. So if empty squares count as 0, or another way you could do this is if not any, either way, then you return empty. Okay, this is a draw. The game is over, it's a draw. Now I want to think about how to evaluate a game recursively. So let's go ahead and take a look at all of the possible positions from this point and see what we get. So I will say var outcomes. And so we will start with game empty squares select. And look, it predicted the right thing. It might have done that because that code is on the other tab. But so for every empty square, it's going to recursively call evaluate with that game. And then because I'm doing a dot select, it's going to gather them all up into one enumerable. And then I want to use two immutable array in order to gather that immutable or that IEnumerable up into one collection. That way it doesn't have to regenerate it every time I iterate it. And the reason for that is that I'm going to iterate this set of outcomes a couple of times. If I didn't have the two immutable array, every time I restarted, it would restart the recursion. So it would be a pretty inefficient algorithm. So let's think about what does it mean to evaluate a win. So I'm going to make a move. If I were to evaluate each one of the possible moves, if any one of them is a win for me, then that's the move I'm going to make. So if from this position, any one of them is a win for me, then this position is a win for me. So let's write that out. If outcomes.any outcome is equal to the next player, then it's the next player's game. That's the move they're going to make, and they will have won. So now I've ruled out that erase that prediction. That's an incorrect prediction. Now I've ruled out the fact that I can win by making a move. So now I'm just going to play for a draw. If any of the outcomes is a draw, I'll be able to play for a draw. So if outcomes is symbol empty, then I return symbol dot empty. Yeah. Okay. So now it figures out the right thing. So if I can't play for a draw, that means every possible outcome is a win for my opponent. So therefore, the game is a win for my opponent. So if I'm X, then it's an O. If I'm O, then it's an X. So that is how we can recursively evaluate a game to see who's going to win. So let's go ahead and evaluate my game. And it says it's a win for X. Nice. What is that symbol? That's a weird looking thing. Huh. Oh. Let's break that down. Let's see what all of the different evaluations are going to be. So let's go with game dot empty squares, and I'm going to select for each index. I'm going to do the evaluation of that next game, but then I also want to take that next game. You know what? Let's do this in 2 steps. First of all, play the move. And then, now I've got that next game, I'm going to evaluate the game, but then I'm also going to say game.html with outcome. So I can show the evaluation inside of the HTML. That's what that one's for. So, does everyone understand what that's doing? So first of all, for each empty square, it's playing that move and giving you back that game position. Now it's got that enumerable of games, and it's saying, okay, for each one of those games, evaluate the game, and then show me the game with the eval on the bottom. And that way, I can see if X plays here, X wins. If X plays here, he wins. Here he wins. Here he wins. There's the next win. Oh, that one's a draw. And that one's a win for X. So now we've explored that space, and we can see where X can play that leads to a win. And now we can just randomly choose from one of those and make that move. And now with this recursive function, we've been able to create some intelligence that can play tic-tac-toe. And we're able to do that because of the fact that game is immutable. And I don't have to worry, as I call evaluate, that the game might change inside of that recursive call. I know that the one that I've got is still going to be the one that it is. That can't possibly change. I've made that design decision up front, and then I'm just enlisting the compiler to help prove that that's the case. Cool. All right. Yeah, I'm doing pretty good on time. We've already talked a little bit about identity. Let's go even deeper into identity. And then we're going to bring this back to this whole immutability thing. So, one of the languages that you can do in Polyglot Notebooks is SQL. So I'm going to choose SQL. And then I'm going to set up, or actually, I'm sorry, for the setup, I have to start with C#. You know, let's walk it through this way because it gives you some pretty good instruction. So what if I wanted to select star from customers, blah, 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 and run it. And then it says, oh, this is how you use me. OK, perfect. So let's go ahead and copy this into a C# cell. So up here, I will write some C#. Let's bring in that NuGet package that does .NET Interactive with SQL Server. And I think this means any beta version, but I like how it just looks like a little weirded out face. So weird guy saying, I have no idea what this SQL Server thing is, but I'm bringing it in for you. And then here, we can create a connection to SQL Server, and I will call that connection school. And here's the connection string. So initial catalog school. OK. So run that in C#, and recognized argument. Wait a minute. Now you can connect to Microsoft SQL by using this. Did it have to be in a different C#? C#, connect to that. I want to call it school. And I want to use initial catalog school. And we'll bring in the package. Yeah, you know what? I don't think I ever did install the package. So there we go. Now it's there. A connection was successfully established with the server, but then an error occurred during the login process. Yes, the connection string doesn't have this extra little bit now that you need to be to trust server certificates through. OK. Now we are connected to the database, and we have this little magic string right here that's been set up for us that tells Interactive Notebooks that that's the data source I want to connect to. So if you're using this for any kind of sharing your results with somebody else, this is a great way to do that. You can connect to the database. You can run your queries, capture the results, write your text around it, share those around. So that means that here I can do SQL school, and I can start to write some SQL in here. So I happen to have a table called course. I like to use singular table names because to me a table is not a collection of rows, it's a data type. This is the course data type. But opinions differ. I want to actually build that that table with you. So I'm going to drop table course. Oh, cannot drop it because it does not exist. You don't have permission? Oh. Oh. Well, of course I can't drop it. There we go. All right. So let's go ahead and create a table the way that that we often would. And it makes a prediction about how tables tend to look. And yeah, that's a pretty good prediction. So I want to create a table. It's got an auto-incrementing ID. It's got the title of the course, number of credits. We even declare a primary key. That's good. All right, we've got that course table. So now I can select star from course. And I need my magic string in order to make that connection. There we go. 0 rows. OK. Let's write an insert insert into course, providing the title and the credits. Sure, we've got some courses. Boom. And now we've got our courses. So good little tool. Now let's suppose that I was building an API. Let's just focus on chemistry right here. I'm building an API, and so you've got this RESTful method. You can do an HTTP post to this API, and you provide chemistry and 3 credits, and then it does the insert into the database. And then what if that API times out? What happened? Did it insert? Did it not insert? I don't know. What do you have to do? Have to try again. So we try again. Second time it works. Okay, great. But you know what? It actually did work the first time, and now we've got duplicate. We've got 2 courses for chemistry where we only wanted 1. Common problem. This is just our default how we do RESTful APIs. We do an HTTP post. If it fails, we try again, and we let the server generate the ID. And that leads to this, but there's a solution. The solution is to take control of identity. We understand our model better than the system does. We can say, I know what the identity of a course is, and it's not that number. It's not even the name. It's certainly not the number of credits, because most of these have 3 or 4 credits. The identity is something that I didn't put into my table to begin with. So let me drop table course. And then what I really wanted in here was a code. So we'll do this in varchar 10. And we'll say, okay, the course has a code. All right, now we've created that. We've got no rows. So now instead of just title and credits, we also have to pass in the code. So we will do Chem 101. Okay, so we've got that in there. That's all good. If I try to insert a duplicate, I can still insert a duplicate because I haven't told it that that's the identity of the table. How do I tell it that that's the identity of the table? Yeah, we've got the primary key that we use as the course ID. So we could change the primary key to the code. We could do that. But that means that all the foreign keys are going to be these character strings. That starts to slow things down, and it takes up a little bit more space. The way I prefer to do that is to instead use an alternate key. So we can do that by, let me just go ahead and do this in a new SQL statement. So I'm going to create this one, unique index. Yeah, there we go. So I'm going to create a unique index on the course table, and I'm going to use the code, the column code as that unique index. So that's going to mean that is an identity column. We cannot have duplicates of that value. Of course, right now, it's going to say, nope, can't do that because I already have duplicates. So let's fix that. Truncate, and then create the index. Okay. Now it's empty again. Okay, so now I can insert chemistry. Got chemistry in there. Insert it a second time, and boom, get an error. Okay, we're making progress. We can't have duplicates. But now let's think about our API again. I've done this HTTP post, and it timed out. So now I'm going to retry. HTTP post. And then I get a 500? No. I want to get a 201 created. Good job. So that means that I want to change this around. And let's do select this where not exists, and one. So it'll insert it if it doesn't already exist. But if it does exist, it inserts nothing. And everything is okay. So now we can fix the incorrect syntax near comma. Somewhere I've got a comma that's not happy. Select that where not exists. Yeah. Yeah, so it's, yeah, this, we do want it to be that. Well, I do have a working version over here, so let's, hey, take it. All right. Oh, that's right. You don't put parentheses around the select like you do the values. Okay, there we go. All right. So now 0 was affected. It didn't actually insert anything, but it still returns okay, and they don't have any duplicates. So this is getting kind of close to a pattern that that is pretty common. Does anyone know which pattern I'm thinking of in SQL? Called the upsert pattern. Anyone use that one? Yeah. Yeah. So upsert is, here's some stuff. If it's not there, insert it. But if it is, update it to make it that stuff. Yeah. I'm sorry. What's? Okay. Entity framework. Entity framework is going to, yeah, that's fine. Yeah, entity framework is going to, you're going to explicitly tell it whether you are adding or updating. So yeah, you'll probably do a select first, and then if you get back an object, then you'll change the object, and then you save changes, and that'll turn it into an update. But if you didn't get back an object, then you'll do a dbset.add, and then it will, when you save changes, do an insert. So yeah, by the time entity framework generates the SQL, it already knows what your code did. Yeah. Yeah. So yeah, in fact, so this kind of code, this you could write in entity framework and generate it, but I don't think you could actually write the upsert pattern itself in LINQ and then have entity framework generate an upsert. I don't think so, but yeah, if somebody has, let me know how. But this is not upsert because I'm not doing an update. I'm just doing an insert if not exists. And now let's kind of tie this back to what we talked about with immutability and identity. So we've got this code, which is the identity that I want to use for the course. But then I'm also passing in the title and the number of credits. The title I might want to change over time. Number of credits I might want to change over time. These are not immutable. And so it becomes a bit of a challenge if you want to keep mutable and immutable things in the same record. You can no longer use that entire record as the identity, which means that you have to do something like upsert in order to be able to update the mutable portions of it. What if, instead, you were to take all of the mutable bits and move them to their own separate record? What kind of monster would that look like? Well, I'll show you. And for this, I'm going to switch away from SQL, although you can still accomplish what I'm about to show you in a SQL database. It just takes a lot of steps. And now I'm going to switch to Janaga.net, which is a library that I maintain that basically takes these concepts and lets you model your systems using immutable records as identity. So if I were to do this kind of thing in Janaga, well, first of all, I need to bring in Janaga. So NuGet Janaga. So bring that in. That's not SQL. That's C#. Oh yeah, and also I'm going to bring in another NuGet package called janaga.graphviz. And then I'll say using Janaga and using janaga.graphviz. Okay. Installing those packages, and now those are available to me. Okay, so now I want to model a course. I'm going to model that as a record. First of all, I will define the fact type, and I will say that's a school.course. And then instead of a class, I'm going to do a record called course. And now the course is not going to have all of the properties of the course. It's just going to have the immutable ones. And the immutable ones are also the identity. So I'll have code. And that is all there is to a course. But I hear you asking, where am I going to store the title of the course? I'm going to store that in a new fact. So we'll give that the fact type title. And we'll say that this fact is saying that for this course, the title is this value. And then let's do the other one for credits. And yes, it figured out the right pattern. Good job, little Copilot. So let me show you what this looks like. I'm going to use the renderer to render types. And I'm going to say I want the type of course course title, type of course credits. And remember, we can render HTML. So, oh, look at that. SVG is valid HTML. So if you call GraphViz, anybody use GraphViz? An awesome tool. It's kind of like Mermaid. It's like the original Mermaid. You just give it some text that describes a graph, and then it gives you SVG. So I just call GraphViz, grab the SVG, stick it in an HTML string, boom, it goes up. So this is the graph that you end up with if you have those types. So you've got your school course at the top, and then you've got course title is pointing to it, and course credit pointing to it. So a little bit of terminology that I like to use here. The one on the top, that's a predecessor. That's something that must come before. So you have to have a course before you can give it a title. And then the ones below are successors. So you got predecessor, successor. That's the terms that I use there. So what does it look like to actually create a course with this stuff? So I'm going to have a trig. So that's going to be a new course. Trig isn't Math 101. No, that's a 210. And then I want to give it a name, so I'll create a new course title, giving it that name. And then if I want to render that graph, I can render not the facts, but now, or not the types like I did before, but now I'm going to render the facts. So trigonometry and trigonometry title. So now I've got these immutable records. So an immutable record that identifies a course by the code, Math 201, or 210. And then another immutable record that says the title of that course is trigonometry. Okay? So far, so good. Now I can refer to that course by its immutable code, and everybody knows which course I'm talking about. But then now I need to do some extra work in order to figure out what is the title. And I have to look at more history, more facts to figure that out. So basically, I'm going to project those facts and figure out what the title is. There's a nice language for querying objects, records being objects, and and projecting them into data structures, and it's link. So I'm just going to say, let's create a specification that is the titles for course, and that is going to be given a course. I want to match. Let's see. Actually, there's no parentheses there. That's why. Yeah, match. And now here I'm going to say I want a lambda that is the given course, and this other thing that I'll call fact. This is a nice little repository that I can use. So I want to find all the facts of type course title. That's where the title dot course, so the course that this is pointing to, I'm looking for this guy, where this course is equal to that parameter that we just passed in. Then once I've got those, let's select the actual title value out of that. So that's going to be my specification for the titles for the course. And now I can run that specification on these objects. In order to do that, I need to put these objects into a collection. So let me go ahead and create that collection here. I'm going to call it J equal to janaga.create. I'm going to do create clients. Oh, yeah, okay. Clients. Why are you not able to find it? Using Janaga. Oh, yep. I don't even know my own stuff. Client.create. There we go. Okay, that's looking better. So now I'm going to take these facts and I'm going to put them into that collection. So I'm going to await j.fact, add that fact there. And then I'm going to await j.fact and add this fact here. Okay, so now I've got the same fact, but now they're inside of this Janaga client, which means that now that I've got this specification titles for course, I can do a var titles is equal to await j.query. So query that same client for those titles. And then I output them and I get trigonometry as an array. Okay, so given that course, I've run this query. I've found all the titles that point back to that course. So a little bit of a twist from the way that you often think about mutable properties as being a thing that you can just go to the object and say, hey, what's the value of this property? Instead, you have to look for related facts in order to resolve that. The reason that we go down this path is that that allows each one of these immutable facts to be immutable. And then I can use the type of reasoning that we used before to really search a space and figure out what's going on. And now the space that we're searching is the data model of our application. But there's a problem. Let's suppose that we were to come back up here and let's do trig title awaits j.fact new course title. So instead of trigonometry, we're just going to call it trig. Okay, let's render out all of those things so we can see what we have wrought. So now we have two titles that both point to the same course. Which one is right? I don't know. The model didn't capture that. It didn't say that I created this one and then I replaced it with that one. And so that means that if I run this specification now, I get back both of the titles. How do I know which one is right? This is a weird system. Why would I do things that way? So, yes. Yes, precisely. Yeah, this client is in memory. And so, yeah, the provider that we're currently working on is SQLite, which is going to support MAUI development. So really excited about that. So we'll be able to take this and use it in a mobile app. And there's a really good reason that this is powerful for mobile app development, and that is that immutable data structures used in this way are really powerful for offline capabilities. You can take this immutable graph of facts. You can add to it on your device without connecting to the server and run these queries, and things continue to work. But then if somebody's making a different change, they're recording different facts, building the graph in a different way. You connect to the server, it just merges the graphs. And then you figure out, what does it mean for the graphs to merge? Which seems like a really strange way to think about programming until you think about, how do you write your code every day? You put immutable commits into a Git repository, and then you push those up to a remote, and other people pull them down, and then everybody can see the set of branches and figure out what happened. It's the same concept. This is just applied to your data structure instead of your code. So this is really exciting. This is what the provider said. But yeah, another thing that you can put in here is not just the provider, where to store the data, but also that upstream. So you can say, that is my HTTPS:// send the data over there. And now you've got an endpoint, a single endpoint that pushes and pulls your entire data model. So that's cool stuff. I'll come back later and I'll show you building a MAUI application using all that cool stuff. But first of all, we have to finish it. So yeah, how are we going to figure out which one of these replaced the other? We have to actually build that into the model. So I'm going to come back up here, and I'm going to change things around a bit. So in addition to the course, the title, I'm also going to have a course title array called prior. Do the same pattern down here, course credits, an array called credits, or prior. So what this represents is these are the prior versions of this property. So if this is the very first time, so now I do that and I see I've got these self pointers, so prior is of the same type. So if this is the first time that I am naming that course, then I give it an empty array. But if I'm changing the title, then I give it an array that contains the prior version. And that turns the graph into this. And now it's pretty easy to see which one is the current version. It's the one on the bottom of the history. It's the last one. Another way you can think about that is it's the one that does not have a prior arrow pointing to it. So prior, when the arrow points up to your fact, that eliminates your fact. That should not be included in the projection. Which means we can come in here and we can change the projection. Right now, the projection is still giving us all of the different versions. But let's say I want where the title course is pointing to the course, and there are not any facts of type course title. We can actually collapse that right in there. There are not any facts of course title where prior called, it completely messed that up. There we go. Okay. And I'll call that one next. Next is the one that I'm looking for, where next prior contains this title. Let's see, facts of, oh, not any. There we go. Okay, so yeah, we're saying I'm looking for the titles that point up to this course. So both of these count, because course points to that course. But then also, there are not any facts that satisfy this condition, that they're the next fact and next prior, which is an array, contains this title. So if we were to look at this one, trigonometry, there exists a fact, we'll label it next, where the prior collection contains trigonometry. So that means trigonometry is out. For trig, there is no such next fact, so it stays. So that's why when I run this, I get just trig. So a bit of extra work for you to kind of get back to this idea of being able to mutate a property. But you've done it by modeling that mutation using immutable records. So now let's come back to this mobile application. You're offline. You change some data. You modify a mutable property. Somebody else on their mobile device changing that same property. Then you sync up. What does your tree look like? Let's try it. Your tree would look like this. So I'm going to data fact, new course title, and we'll call this other. And rather than building on to trig title, because I didn't learn about that one, I still think that the current title is trigonometry. So I'm going to build my title on trigonometry. Which means I will end up with that. There we go. I will end up with this graph. So I started with trigonometry, and then I created trig, and then somebody else created other. So now I'm back to a graph that doesn't have a single leaf. It doesn't have just one thing at the bottom, which means when I run this, what am I going to get? Both of them. So imagine that you are building a mobile app, and you can use it offline, and you can get into this state. Now you run this query, you get back more than one result. You know that a concurrent edit just happened. And these are your candidates. You can present them to the user and saying, hey, there was some kind of conflict here. Both of these things happened. Which one was the correct one? Let the user choose. And when the user chooses, now this is why prior is an array. You can create another fact that has both of these as prior. And it will stick them back together and give you a tree with just one leaf. If this was Git, these would be two branches. Stitching them back together is a merge. A merge is a commit that has two parents. You're just modeling your data structures the same way. So that is how you can take these ideas of immutability and identity, bring them into your data model, model your application in that way, and you get some really amazing benefits out of that. So thank you so much for spending some time with me this evening. Any last questions? Datomic, yes, yeah. It looks a whole lot like Datomic, yes, it does. Yeah, basically, it took a little bit of inspiration from that, took a little bit of inspiration from some math papers that I've been reading. Pat Helland is one of my favorite authors, and he writes about immutability. one of his papers is called Immutability Changes Everything. It's just an exploration of all of the problems that are just really easy to solve once you introduce immutability. And this is also based on the work of Mark Shapiro and Nuna Pergusha. They wrote a series of papers that describe conflict-free replicated data types. And this graph is a CRDT. Conflict-free replicated data types have the property that they will not create conflicts. Even though I said that's a conflict, it's really a concurrent edit. But then everybody can see that that concurrent edit happened. It's not that one person has one state and another person has a different state. There is no conflict. And so this is conflict-free, and you can use these ideas in order to build these data structures that then replicate conflict-free replicated data types. Yeah. No, go for it. Oh, yeah, yeah, tail call optimization. Mm-hmm. 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 Yeah. Yeah. Okay. So first of all, let me explain what tail call is all about. So, so this particular recursive function could not be optimized with the tail call, and that's because the call to evaluate is right here in the middle. In fact, it's even worse than that. It's inside of a loop. So there's just absolutely no way that you could optimize it. But for some recursive algorithms, the recursive call occurs at the very end. There is absolutely nothing else that happens after the recursive call. When that happens, the compiler can optimize that and say, okay, rather than push a new stack, I'm just going to turn that into an iteration. I'm just going to loop back to the top of the function because I know there's nothing else that comes after. Just replace all the parameters, go back to the top, keep on going. Just turns recursion into iteration. So it is very important for a language to support tail call. And it's also very important for the people who write the library for that language to understand how to write a recursive function that can be used with tail call. But once you get past those fundamental building blocks, then as an application developer, it's very uncommon that you will find an algorithm yourself that can use a tail call optimization. Instead, you'll be using one of the built-in ones, like fold. So fold is basically give me a collection, could be, for example, a collection of numbers, and then apply this operation to every element in that collection. That operation might be plus. So if you fold a set of integers over plus, it's just going to add them all up. You have to give it the seed value of 0, and then add them all up, give you the sum. You can imagine doing that with a loop. You could also imagine writing that recursively. In a tail call language, then you're going to write it recursively. You're going to express that as a function that could be optimized using tail calls. Sometimes you have to express it. In some languages, it can even figure that part out. But then, so somebody writes that function fold, and then makes it part of the library, and then you never have to think about that again. Mm-hmm. Yeah. It does. Yeah. It's called aggregate. Yeah. LINQ has all of the things that we're used to in your traditional functional programming languages. They just have different names. But yeah, LINQ aggregate is the fold function. And LINQ select is what other languages call map. And select many is what they call flat map. Yeah, aggregate, sometimes called fold, but in other languages it's called reduce. So different names, but they all mean the same thing. That's what I found, yeah. Oh, yeah. Mm-hmm. Yeah. Yep. Mm-hmm. Yeah. Yeah, I would say prior to the introduction of records in C#, that would have been the case. I still wanted to have Janaga.net be C# based rather than F# based, strict, just for reach. I wanted to be able to support Maui, and when Maui was first introduced, it didn't support F#. I think it does now. It's been a year. I think they've added now. But yeah, because that's what people are already used to. Let's just go ahead and give them the tools and what they're used to. And now that once records were introduced, it's like, okay, that's it. That is what this API looks like. It's records and LINQ. And yeah, so yeah, I would say that the language has picked up enough functional bits for me right now, especially with pattern matching being really powerful now. That I'm comfortable with that compromise. I don't need it to be any more functional. Mm. Yeah. Uh-huh. That probably would work. Yeah, because basically the key to making that work is just this HTML string data type, which is probably what Razor's using under the covers. Yeah, that comes from ASP.NET Core HTML. Yeah. So you just build up a string. So this string has the style feed in it, and then it has rows and cells. Oh, wait, that's string as well. And then you just shove that string into an HTML string and return it. And then if that's the thing that the Notebooks renders, you're getting that HTML rendered. So yeah, I'll bet you that'll work just right out of the box. Mm. Read-only collections. Yeah, that's interesting. Yeah, so I think read-only collections came before the immutable collection, and I see them as a useful compromise. So with read-only, you can basically have like a list, and then you say, I'm just going to fill up this list. I'm going to treat it like it's immutable, and then at some point you say, all right, now I'm going to freeze it. I'm going to return this as a read-only collection, which does absolutely nothing to the underlying data structure. So it's not like a brand new allocation and copy or anything like that. Just, nope, it's that same data structure. We've just turned off all of the methods that would mutate it, and they now throw non-implemented exceptions. So, so yeah, that's a reasonable compromise. Yeah. Yeah. Hmm. So if you go up to, sorry, I have the link in here, so I can just click the link. This one. It's the link. Oh. Yeah, so if you look at the IPYNB in GitHub, then it renders it almost. It doesn't do the HTML trick. So, but it does do the SVGs. So at least you have that. So yeah, and notebooks support Mermaid, so you can just put Mermaid into the notebook as a code cell, and then it would render it out, and you would still have the code that generated that Mermaid. And then yeah, if you're using GitHub, then you would see this. I don't know if Azure DevOps supports this yet. Yeah. Yeah. Yeah, but this is really useful for when you're collaborating with your non-technical cohorts, and you just write your notebook, check it into GitHub. They don't even need to have a Jupyter notebook or interactive, or it used to be called interactive notebook, Polyglot Notebook extension on their machine. You can just go to the GitHub page and see it. Not that I've seen, but that would be kind of cool. Yeah. Hmm. Yeah. Yeah. So some of the problems that Pat Helland explores in that paper are things that are implemented at the operating system level. So so things like how space is allocated on a disk, and so when you want to overwrite part of a file, so you've got your file, you want to just change some of the characters, the values inside. The way that an operating system will do that is it will allocate a new page, put the new stuff in there, and then it'll have this table that says this file is this page, that page, this page, this page. And you end up with a thing called structural sharing, where when you change the structure of a thing, you get to share the old version and the new version, some of the old blocks. But then the old version is this table, which points to that old block or that old page, and this the new one table pointing to the new page, but some of the old stuff. So yeah, and if your operating system allowed you to actually, it doesn't go into this in the paper. You kind of stopped there with that example. But but yeah, if your operating system supported an API that was immutable, like kind of like the APIs that we saw with these collections, then you could still have the old file and you would have the new file, and they would both be valid. You'd be able to read both of them, and you wouldn't have a complete copy of the old file and the new one. So structural sharing is a pretty powerful technique when you're using immutability. Yeah. Yeah, I think in that paper he does go into distributed caching. I know I know that in a lot of other papers he talks about eventual consistency. Yeah, he was. Yeah, I think Pat Helland was on the team that designed the distributed transaction coordinator. Don't hold that against him. He's actually brilliant. But yeah, he does have a paper that describes all the problems you had to solve to make DTC work, and these are the solutions. And it was crazy. Which basically, after reading that paper, is like, I never want to depend upon the DTC because it's doing a lot of work. Yeah. 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 For me, like right here, I say, have a human being come in. So yes, go ahead and show these two values to the human being and let them decide. That's the solution that we use in Git. You know, if you do a merge and they can't figure out what the merge is, human being decides. I'm not a big fan of the automated conflict resolution strategies for two reasons. First of all, they have to run somewhere, so that means they're probably running on a server, and that's probably a centralized server, and I want everything to be able to be decentralized. And then the second problem is they have to run when. They have to run at a certain time. And the time at which you choose to make your conflict resolution is going to influence how you resolve the conflict. So with things like conflict-free replicated data types, you can prove that as soon as everybody has the same information, everybody comes to the same conclusion. But if you have a conflict resolver somewhere in your network and it's spewing out conflict resolutions, then the order in which it receives its information is going to change the resolutions that it spews out. Imagine that you've got two people on your on your development team, and they both try to merge the same branch, but they make different decisions on how to do it. Then when they both push their commits, you're going to have another conflict, and you're going to have to try to resolve that again. Mm-hmm. Yeah, exactly. Yeah, but the absolute worst conflict resolution strategy is last writer wins. That's just a complete cop-out. Never use that one. It's like, you made a change? No, clobber. Cool. Well, thank you very much. I've written a book. It's called The Art of Immutable Architecture. So if you want to get in, really deep into this stuff, then dive into that book and yeah, give me a call and we'll talk about it. Cool.